Hello, everybody. Um, name's Michael Gorham. I'm CTO of ConexED, and AI has been a passion of mine for quite some time. I remember studying optical character recognition way back in the 90s, along with neural nets, and I've been experimenting with OpenAI's API since GPT-2, and I've kind of seen the evolution of it and how it's just exponentially taken off in the past year or so. Um, and really, it's for us implementing a large language model or chatbot has been kind of a fine dance between cost and benefit. Right now, it's the cost is dropping um, pretty quickly, and there are competing models out there that are like Amazon's Bedrock um, and Google's Bard that are becoming less, which becoming less expensive and pushing down the price. So we have a lot of exciting things in store, and we've been working on um, several features that we want to introduce relatively soon. We'll go over that in detail in our IT roadmap. That's a presentation that's scheduled for tomorrow. But for right now, let me move on to the next slide. Go over the agenda. Uh, I'm just going to give a quick overview of AI, the tools available right now. ConexED AI roadmap, um, which is basically the two main features, automations and our chatbot. And then we'll wrap it up with a question answer session. So I don't want to dive too deep and become too pedantic, but there are two areas of interest uh, that we have: machine learning and neural nets. Machine learning is basically predicting future trends on historical data. There's supervised, unsupervised, and reinforcement learning. Supervised trains on label data to classify new data accurately. It's pretty expensive because you have to go through each row. If you think of tabular data, like a spreadsheet, you have to go through each row and label the row as being, how we want to predict that row. Is that, for example, if it's a student, their grades, is that grade a good grade or a bad grade? And basically classifying each row. It's a little more accurate, but it's very time consuming and expensive to have to go through and label so much data. Unsupervised learning is an attempt to actually do that labeling automatically, but it's not as accurate. And then reinforcement learning is kind of trial and error and optimizing decisions over time, which is a little bit more accurate than unsupervised learning. And so machine learning, we on our roadmap, we plan to use that with our automations feature. And automations is basically taking filtered subsets of data and automatically taking actions on that data. So if we train a model on students that are likely to drop out, then we can run a nightly process and just pick out, like, these are the top 5 students that advisors, counselors, or tutors need to really reach out to and kind of re-engage them and get them back on track. So that's kind of that's our target. That's where we want to get to. And then next is neural nets, which is uh, really what the explosion of ChatGPT has. It's based off of neural nets and using generative pre-trained transformers, which are generative, meaning it looks at a sampling using a predictive model, looking at previous words and trying to predict the next word. Pre-trained, meaning it's the training is, the patterns are based on, at least with ChatGPT, it's based on question answer pairs. So it's tuned to answer questions better than just predicting the next word. And then Transformer is, well, it was originally designed by Google to translate languages, like English to Japanese or um, natural language processing. So within GPTs, we have two options to really get that question answer kind of chatbot paradigm, and that's either through fine tuning or retrieval augmented generation. And fine tuning is kind of like taking that pre-trained data set and training it just a little bit further. It's a little expensive and a little fickle as far as like getting the data, getting a chatbot to perform accurately. We've experimented with it a little bit with, we have, ConexED's been around for 12 years and we've gathered a ton of chat data just between our knock on door one-to-one chats and our lobby chat. We have millions of rows of interactions between students and advisors. And I think long-term on our roadmap, we want to be able to fine tune and train chat bots based on specifically a school's data set and not really like everybody's data set, but really tune it to uh, just like maybe a specific school in California that is, set to a certain student population, and they get these questions asked over and over and over again, and it can just give that answer back because it's been trained. Retrieval augmented generation is a lot easier to implement. It's basically taking like a frequently asked question and searching across those frequently asked questions and then injecting the results of a search into a prompt and then returning the response. And that's where a lot of our work has been targeted at. It's a lot easier to implement. It's the low-hanging fruit. So that's where we're going, I think, with retrieval augmented generation in the next month or two. Vector databases and chunking is just basically a way to search databases to embed that augmented generation into a prompt. And then reinforcement learning with human feedback, that's we will be implementing that. We have that a little bit. It's kind of like we ask our chat, a student comes in and asks the chat bot, how do I register for courses? We return an answer, and then there's a yes or no. Was this answer helpful? If it's not helpful, we'll go in and look at the question and see if we can tune that a little bit so that the next time that same question is asked, we give a better response. Optical character recognition is kind of a pet project of mine. But I don't know if we really will implement it into ConexED. It's just I put this on the slide because it's an easy way to visualize what ChatGPT is doing under the hood. So I've got actually a little video of optical character recognition happening, and I'll play this. You guys can see it. I need to slow it down. But basically, optical character recognition is this particular use case. It's just numbers, and it's trying to predict or trying to identify which number has been written. And the way this happens is we've got a grid of 28 rows by 28 columns. And in this case, it's a three-dimensional neural net where it's looking at relationships between these cells. So the XY coordinates, as well as the, at the edges, you can see like the, from one or 0 to 1, the amount of gradient is on that particular cell. So let me pause it for a second. So like on these edges, it's not a full, it's a gray color, but in the middle of it, it's a white. And so it's looking at, is that particular cell highlighted? What scale between 0 and 1 is it highlighted? And are the neighbors highlighted as well? And then it takes that, and in the back, it meshes it together um, to the neural net layer that's been trained. And then based on the relationships of these cells, it'll pick the number back here that has been, it correlates to that pattern that was drawn. Now
Hey,
this is,
Michael,
yes.
really quickly, can you give an example of where this OCR would work for a college? Like, where would they use this?
Well, OCR that would be maybe transcript uploads. Uh, that was kind of a project that we explored a little bit. If a student comes into a chat and then they upload their transcripts, we could use OCR to translate that picture that has been uploaded to text and then kind of process, all the courses that they've taken and put that into our database without really any human intervention. Um, but I bring up this neural net visualization because this is really a three-dimensional uh, net. And when we look at ChatGPT, that is actually it's 12,000 dimensions. So that's why it's just exploded in the past year, is that we figured out how to take these calculations and scale it to 12,000 dimensions of relationships in the back end. And it's basically, we can predict words based on the meaning of previous words. Um, Basically, words with similar meanings are grouped together in the vector space together so that we can predict the next one. So um, let's get back to the, there's the visualization. Actually, let's back up to automations and the machine learning side of our roadmap. So automations is our feature that we want to basically, ConexED has a unique position in the market where we can actually triangulate data between learning management systems, student information systems, and our own system that collects interactions between advisors, counselors, and tutors, and basically build a picture about a student population and flag certain students that are at risk of dropping out or whatever whatever rules we set up. So LMS is basically attendance for the learning management system. So you think of Canvas or Desire to Learn or Blackboard. We can find out when the student last logged in, the number of page views, the amount of activity they've had in the learning management system, um, and pull their grades and activity from the learning management system, and then correlate that with SIS data, which would be demographics like how old are they, how many previous credits have they taken? I mean, are they like a first year student or are they well along um, their academic career? Also attributes that may exist in the SIS system, like is that student an athlete or are they EOPS? Um, Along with their major, the program plan, and the assigned advisor, and kind of build this multi-dimensional fingerprint or pattern for a student, and then be able to apply machine learning to pick out the students that really need attention. So with that said, I'm going to toggle over to our automation screen and just give a little quick demo of what we've built and will be rolling out in the next several months.
So really quick, before you dive into that, because I put out a poll to see what the scale of familiarity was with AI, and I'm sure not shocking to you, are a little all over the place. So just to rephrase that, basically what you're saying is our AI that you're building will take in information from our system as well as information integrated with the SIS and LMS to paint a broad, high-level picture of the student, identify patterns, and then even maybe be able to apply a severity or level of need, or even maybe a reason why the student is falling behind or in need of some sort of support. Is that right?
Yeah, that's correct.
Awesome.
So the automations portion of it is basically these are taking sets of data and applying actions to them automatically. So we down here we have it's a list of students. We have their grades. We have the major that they've taken or they've signed up for. But we have these actions that we can take on this set of students. We can assign an attribute, remove an attribute, add to a cohort, remove from a cohort, create a case, resolve a case, or send an early alert. Sending out early alerts is really what started this whole automations feature. We wanted to on a nightly basis, look at all the student population and flag certain students that look like they're falling behind or need more help, and then send an alert to the student's advisors so that the advisor can reach out to the student, check in with them, see if they can get the student back on track. So for this particular automation, if a student matches a criteria, we will assign an attribute. In this case, it's an academic alert, and then send a poor grades early alert. These alerts are created in our alerts, manage alerts section, and same with attributes. They're created in another part of the system. And then, so we send these out nightly to define the rules that cause these actions, that trigger these actions. We have a set of fields that we select, and these fields are either from the SIS, the LMS, or our own data. And then we can build up a list of however many fields you want to apply. Uh, that list that's not constrained. I think maybe we have 10 conditions that we can define. So when I run it, it's going to apply that filtering condition, and we'll see the subset of students down here. Right now, that's 0 because I don't think we have anybody with a TH as the last name, so we'll remove that. Run it again. And you can do this as many times as you want to see what the results are, and even drill down into the student record just to kind of tweak the filtering parameters. And then when you're comfortable with that, you can go ahead and run the automation. We have a history shown here of all the times that the automation has ran. And then I'm going to drill down to the automation log. We see what actions were taken. We can roll back the automation if we executed it accidentally. And then clicking here, we can open up the student's record and actually have that. Maybe I don't just open it up. So we applied the academic alert attribute to all these students, and we sent a poor grades early alert. So we go to Haley's record, you can see that the attribute has been applied. And if I go to the proactive alerts tab and view the alert that was sent, part of this alert, I included the students' grades. We don't have to include this if it's a privacy concern. It's actually an option is as part of the right here, include student grades. And then we can classify the severity of the alert based on the grades and create a synopsis using a large language model of the student grades. And it'll also take in the comments that the instructor might have added for that in the grade book for that student.
So for those that have played around with ChatGPT a little bit per our poll, basically, Michael, what you're saying is these automated alerts have a little bit of AI in them where going back to what we were saying a minute ago when I chimed in, ChatGPT not ChatGPT, the large language model is looking at the collective view of the student per our integrations and within the system. And based on the alert that you're raising, the AI is coming up with the reason why, or identifying the patterns as to why this student is having these issues or is in need of this particular type of support. And based on that synopsis and that information, it's applying a severity rating.
Well said.
Boom.
Exactly. Right.
Awesome.
Yeah. So yeah, for example, though they showed initial promise, the student has demonstrated a concerning downward trend in their grades, suggesting they're quickly falling behind and not comprehending or applying course material, that sort of thing. So this runs nightly. It picks out students. There's options to not send the same alert to the same student, and you can actually run automations and not trigger any action. You could just not have any action run just to see how it works, how it performs over time. And once you get comfortable that it's picking the right students, then you can start assigning attributes, taking these actions. Now, while kind of exploring the territory of the LMS market, that's basically Desire to Learn, Canvas, and Blackboard. They all have overlap in the data that they're collecting. But I built a graph visualization. This is basically, this will come with automations where you can explore the student population. What we're looking at here is groupings of students and the department that they're in. We can break it into course, but that really gets a little, it's hard to see over a webinar. But what we see here is like, this is the computer science department. We've got all of these students showing up in green, meaning that they've got a course grade average of green would be like maybe 80% and above. But this one student has 40%. And so with these filters, we can hide students that maybe the professor hasn't been working in the grade book, and then filter down and just show students that are really at risk and drill down. So this is just a way to help fine tune the rules that we set up in the automation and identify students that are at risk kind of in a manual way.
That's actually really interesting because, and you haven't, maybe you have, maybe you haven't, but I've been sitting in some other sessions today where the hot topic of conversation was, it's not so much that we don't have the data because we are recording everything. More so it's how we put the data together and how we understand trends and patterns and like, how do we dissect this? How do we make decisions based on all of this data? So it feels like with this visual representation, you can essentially group all of the things that you want to see and effectively be able to come up with something really easy to digest.
Yeah, yeah. It's yeah, sometimes when you visualize the data in different ways, it just the patterns kind of become obvious, and then that's really why I built this tool, is that so that you see these patterns, then you can build a rule around that pattern and then run automations on it. So that's automations. Let's see, it's the demo, and there's this is what the graph looks like with grouped by course. It gets a little more scattered. But you can see also with this 3D visualization, if a student's taking a lot of different courses, they're going to have a lot of links to different nodes. And if they're showing up as red and they have a lot of courses, then you know it's probably the student's overloaded. Okay, so that's automations. We're going to move on to chat, which is the real hot topic, I think, in the industry, with maybe the most potential. So right now we have chat v.1. So as an example, Rio Salado College, so Maricopa Community College, has our chatbot. We basically built a chat delivery system. It's a widget that you can embed on any web page, either inside ConexED or outside of ConexED, or both. So this example is actually a widget embedded on Rio Salado's website. It's live now. It's on every single one of their pages. And a student comes in, asks a question. We have this prompt that's customizable, and we can customize the colors and the logos, the icons. I'm just going to ask, how do I register? And so it's very, very simple, rudimentary. It just goes out, basically does a web search and comes back with a set of links for the student to click on. Not very interactive. It does have feedback, but it's not using any large language models. Now, the reason why we're not using large language models is because we don't want it to hallucinate. There's a lot of, controversy around, it going off the rails and answering questions wrong, or answering questions for other colleges, and not really having the right data sets that, trained on. And it's a couple of that, it's cost prohibitive. Every question that you send off to ChatGPT, you're getting charged. It's fractions of pennies, but it adds up over time. And yeah, some companies are paying millions of dollars a month just to have a large language model. But that's kind of cost prohibitive for us. The prices are going down, which means that we can we can provide it soon. So anyway, this is a chat version 1.0. We're collecting the data on the back end, like what questions are asked and what answers were clicked on. But this is not really the latest and greatest in technology. On our roadmap, we are building, basically taking this chat delivery system and coupling it with a large language model, and using retrieval augmented generation, which is basically, you, as a college, you give us your frequently asked questions, you give us your student handbook, we'll scrape your website, we gather just a document repository, and then use prompt engineering to take that content, pieces of the content, and build up, when a question is asked, we come back, we send that off to a large language model, and it comes back with a nice human readable answer. So for example, this is on this local machine. I've got it wired up to uh, I think it's ChatGPT. And what we did was we took Rio Salato's student handbook. It's a 500-page handbook, um, including the course catalog, its policies and procedures. It's a lot of data. Took all that, put it into a vector database, and basically I can now ask it questions, and it's it's the equivalent of chatting with the student handbook. So, for example, let me find find my list of questions. So, how do I apply for a scholarship? Paste that in. Oh, I need to, sorry, this is a live demo. I need to get things working on my system. Let's retry that. So it gives a little feedback, searching for frequently asked questions, comes back with an answer and a link. Let's see what's another good question to ask. What's the cost to attend Rio? It comes back with the prices that were inside that student handbook. Now here's a really cool question. And this was basically prompt engineering. I said if a student asks a question in any language, respond with an answer in that same language. I didn't have to do any translation. I didn't have to, uh, figure out what language they were asking it in, and I don't know, write special edge cases for that. So this one's hola, las clases de inglés tienen costo que requisitos se necesitan. So basically the same question. How much how much do the English classes cost? So it basically translates, oh, it's not the result I wanted. I think I restart the server. Oh, basically in the previous runs, it would translate the question to English, search the student handbook in English, and then reply in Spanish. No, it's not working. And this is partially why we're not doing the student-facing portion of the chat bot just yet with large language models. What we are planning to do, and I think we'll get this out in the next month, is add the capability to search our own knowledge base, so the ConexED knowledge base, and provide the chat bot for faculty and staff and above, so that if you're an administrator setting up ConexED, or you have a question about the ConexED system in general, you can actually chat with our knowledge base. And let me see my questions. I had a set of questions here. So for example, like what are reason codes used for? So it's going to search the ConexED frequently asked questions, and it will give a reply. Reason codes are used for students to identify the purpose of the visit. And then it'll actually give a link to the knowledge base support article. There's another one. Can I set privacy level for meeting notes? And then it gives that answer back. So as a user of ConexED, faculty and staff and above will provide the chat bot with large language model capabilities that will link to knowledge base articles. This way we'll slowly introduce the chat bot and we can kind of see usage trends, see the questions being asked, kind of fine tune the chat bot and learn from that, and then start rolling it out to the student population where they can actually ask questions about attending college and the student handbook and whatnot. Let's see, going back to here. This is our architecture diagram. I won't dive into it too deep, but we're basically using LangChain, Python, vector database, and React.js for the chatbot. So the far future, so that's kind of the near term, what I just demoed, that going out maybe to the fall or next year, we want to build out an admin UI where administrators can come in and see real-time metrics of chatbot usage, be able to customize the prompts that are used to handle the retrieval augmented generation, so you can really just kind of make little tiny changes to the, if a student's asking about advising, please respond with this answer. And if you don't know the answer, just say, I don't know, make it really customizable, so that you as users or administrators of ConexED, you can just go in and modify the prompts as opposed to having us kind of have to take care of all the different edge cases for every use case. Along with a customizable document repository where you could upload your own PDFs, point to the specific URLs that you want the chatbot to crawl, and then for authenticated versions, which is basically if you're logged into the ConexED system, it'll be context aware of which page you're on within the system. So if you're in the reason code editing page, then it's going to know you're going to maybe asking a question about reason codes. We'll offer different tools based on the role type. So if you're a student, it'll maybe limit the number of tools that you can use, or maybe point you to, like, we have a schedule appointment tool, which you see in this screenshot. Where, I mean, just if you type in appointment, the student's asking about scheduling an appointment, we can actually look at the student that's logged in, look at their assigned advisor, and then just pull that assigned advisor schedule up and see what that advisor's availability is, and potentially just say, hey, this advisor is available Monday at 3:30 p.m., but also Wednesday at 9 a.m., and also Thursday at 10 a.m. Click which one you want to schedule the appointment for. We also want to integrate large language model into the lobby area for advisors. So if a student's asking a question in lobby, we can pre-fill out the answer, and the advisor can maybe change the answer a little bit or review it, and then hit OK, so that they don't have to type out the full answer. They could just kind of have a pre-filled answer for a student, kind of like the autocomplete for your phone. Integration with the ConexED scheduler already mentioned, and other tools like was another good one. Sometimes we've noticed a pattern with the Real Salato chatbot as implemented now, is that people are just typing in live help or live agent, or they know that they're talking to a bot and they want to talk to a real person. So being able to detect that type of usage and just say, hey, it looks like the Welcome Center lobby is open. Click this link and that person will join the lobby and they can see the active moderators in that lobby. And that's seeing this scheduling card as kind of the multimodal output. Multimodal input would be uploading a picture and having it like a transcript and having the chatbot be able to read the transcript and show that information to the advisor or counselor. Well, I already did the demo, so I think that's it for with the chatbot.